Hello dear students, welcome to BYJU'S exam prep. So our today topic of daily dose is how we can apply the engineering mechanics in case of sedimentation analysis in environmental engineering subject. So you know that guys, sedimentation is a very important process of water purification, as well as sedimentation will also occur in wastewater treatment plant also, right? But we have done a lot of time the sedimentation analysis in which we have to find out the settling velocity of a particle. So let's understand how we can apply this particular concept of engineering mechanics in our sedimentation analysis also. Okay, so let's start this particular session guys, and you can subscribe our channel also for further type of lectures or further type of daily dose videos on our channel, right? So as you can see here guys, this is the particle basically, right? This is a particle, right, which is trying to settle down in the sedimentation tank. Now there are various forces which should be applied on this particular particle. So the first two forces are the drag force and the buoyant force, which is applied in the upward direction, right? Fd is nothing as that is our drag force, and Fb is nothing as it is our buoyant force. The second one is basically the self weight of the particle. The self weight of the particle is applied in the downward direction. Now after balancing all these forces, our particle is trying to settle down in the downward direction with a constant velocity, that is basically Vs, right? So guys, we need to understand why this particular particle is moving downward, and the second one is how we can apply the concept of engineering mechanics in this particular analysis. So let's understand with this particular calculation. Okay, so as you know that guys, as per Newton's second law, as per Newton's second law, we can say that the summation of F external is equal to rate of change of linear momentum, right? So summation of F external is equal to rate of change of linear momentum. Now you know that guys, in our sedimentation analysis, the particle is not trying to change its mass. That means our mass is constant. And the second thing is velocity of this particular particle is also constant, by which it is trying to move in a downward direction, right? So can I say that in the sedimentation analysis, the mass is constant basically, and velocity, that means settling velocity, is also constant. If both the values are constant, then what will happen? Let's understand. So guys, summation F external can be written as m dv by dt, then v dm by dt, right? Now we know that if some value is constant and if you take the derivative of it, it will become 0, right? So dv by dt will become 0, as well as dm by dt will become 0. That means if a particle which is moving with a constant velocity, right, then in that particular case, the summation of F external is equal to how much? It should be equal to 0. If it is equal to 0, then only we can apply here Fw minus Fd minus Fb is equal to 0, right? And this is the condition which you have applied to derive the settling velocity of this particular particle. And I think all of you know that guys, after solving this particular equation, you will get the settling velocity of a particle by using a Stokes law, right? So this is the thing which you need to understand, right? And I hope you have understood why we are applying certain concept of engineering mechanics in some of the part of environmental engineering also. So this is one of the fundamental example which I have given you guys, right? So let's meet in the next video guys. I hope you have enjoyed today, and let's meet in the next video in which I will discuss the further concepts of different subjects. Thank you so much.